In the last 3 lectures, we have seen how to find out the digit at unit place with the help of the cyclicities of decimal digits. And now, in this lecture, we are going to solve 2 problems based on the unit place calculation. So let us move on to our problem number 1. In this problem, we are required to find the unit digit of 332 raised to power 40 multiplied to 93 raised to power 24 multiplied to 64 raised to power 41 multiplied to 49 raised to power 98. So we are required to find out the digit at unit place of this multiplication. So let us see how to solve this problem. We know we are going to focus on these powers independently, and we will find out the digit at unit place of these powers one by one. And once we have all the digits at unit place, we will simply multiply them all. So let us start with 332 raised to power 40. Number 332 has 2 at its unit place, and therefore we are going to use the rule we saw in the previous lecture where we did the calculation for the case when we have 2 at the unit place. There we saw whenever we have 2 at the unit place, we take the power and we divide it by 4. After the division, we note down the remainder, and with the help of the remainder, we can find out the digit at unit place. So let us take this power 40 and divide it by 4. When 40 is divided by 4, we get 0 as the remainder. So we can write 332 raised to power 40 as 2 raised to power the remainder, which is 0. And we know 2 raised to power 0 will give us 6 at the unit place. So we are getting 6 from this power at the unit place. Now we will shift our focus on this power 93 raised to power 24. 3 is the digit at unit place, and like in case of 2, we are going to follow the same rule. We will take the power, which is 24, and we will divide it by 4. 24 divided by 4 will give us the remainder equal to 0. So this we can write as 3 raised to power 0, and we know 3 raised to power 0 means we will have 1 at the unit place. And if you are not getting how 2 raised to power 0 is giving us 6 and 3 raised to power 0 is giving us 1, you will have to watch the previous lecture. Now moving on to this power 64 raised to power 41. 4 is the digit at unit place, and we know the rule when we have 4 at the unit place. We simply need to check if the power is even or odd. When the power is even, we get 6 at the unit place, and when the power is odd, we get 4 at the unit place. Here the power is 41, which is odd, and therefore we will get 4 at the unit place. Now moving on to the final power, we have 49 raised to power 98. 9 is the digit at unit place, and we know, like 4, in this case also we check the power whether it is even or odd. When the power is even, we get 1 at the unit place, and when the power is odd, we get 9 at the unit place. Here the power 98 is even, and therefore we will get 1 at the unit place. Now the next step is to simply multiply the obtained digits. 6 multiplied to 1 multiplied to 4 multiplied to 1. 6 multiplied to 1 will give us 6. 6 multiplied to 4 will give us 24. 24 multiplied to 1 will give us 24 itself. Now in number 24, we can see that this 4 is the unit digit, and therefore this 4 is our answer. So this multiplication will have 4 as the unit digit. So we are done with our problem number 1, and now we will move on to our problem number 2. In this problem, we are required to find the unit place of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus all the way to 999 factorial. Now, before we understand how to solve this problem, I request you to pause this video and try to find out the answer on your own. I hope you are done. Now we will move on to the solution. In this, we will first focus on 5 factorial. There is a reason, and this reason will be clear when we write 5 factorial in the multiplication form. 5 factorial we know will be equal to 5 multiplied to 4 multiplied to 3 multiplied to 2 multiplied to 1. In this multiplication, due to presence of 5 and 2, we will get 0 at the end. 5 when multiplied to 2 will give us 10, and because of this we will have 0 at the end. Similarly, if we focus on 6 factorial, then in 6 factorial we will have 6 multiplied to 5 factorial. Now this 5 factorial we already have seen will have 0 at the end, and therefore 6 factorial, which is 6 multiplied to 5 factorial, will also have 0 at the end. Similarly, 7 factorial, 8 factorial, all the way to 999 factorial will have the 0 at the end. This means they will have 0 at the unit place. So we can say that 5 factorial plus 6 factorial plus 7 factorial plus all the way to 999 factorial will give us 0 at the unit place. And now the remaining part is 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. 1 factorial will have 1 at the unit place. So from here we will have 1 at the unit place. 2 factorial is equal to 2 multiplied to 1, and therefore we will have 2 from here at the unit place. 3 factorial is equal to 3 multiplied to 2 multiplied to 1, which will give us 6. Therefore, from here we will have 6 at the unit place. 4 factorial is equal to 4 multiplied to 3 multiplied to 2 multiplied to 1, which is equal to 24. 24 has 4 at the unit place, and therefore 4 factorial will have 4 at the unit place. And now we will add all these digits. 1 plus 2 plus 6 plus 4 plus 0. 1 plus 2 is equal to 3. 3 plus 6 is equal to 9. 9 plus 4 is equal to 13. 13 plus 0 is equal to 13 itself. So from here we will have 3 at the unit place, and this is our answer. So the sum of all these factorials will give us 3 at the unit place.